Welcome back. In this, the first of the technical modules, we'll be covering server virtualization with Windows Server 2012 R2 and Hyper-V. So let's jump in and take a look at the module objectives. So what is it that you're going to learn? Well, first of all, we'll have a quick virtualization overview. So for those of you who may not be overly familiar with some of the terminology Microsoft uses for virtualization versus some of its competitors, or for those of you who haven't really done too much with virtualization just yet, we'll cover off some of the key pieces that you need to know in order to make sense of the rest of the content in these sessions that we're recording. So some of the technologies that we'll cover will focus on networking, so things such as the virtual machine queue, which is an important part of the Hyper-V networking scalability capability. When we look at dynamic memory, this is really all about, how can we get more out of the memory that we've got installed on the system without it really having a negative impact on the performance of the server. We'll talk about improvements to the container that virtual machines are stored in, which is VHDX files versus VHD files, and where you would pick and choose and use one versus the other. We'll talk about some of the improvements in the VHDX file format, including the online resize, which means that you can resize it while the virtual machine is still running. We'll talk about some of the monitoring capabilities that are included. We'll cover off cluster-aware updating. So if you do have a bunch of Hyper-V servers running and you do need to make sure that you're patching them without having an impact on the workloads, this is something you should definitely take a look at. And then we'll also talk about virtual machine mobility, so moving them from machine to machine without interruption to the service. And then finally, we'll wrap up with a quick look at the Hyper-V replica capabilities. So what is server consolidation? Well, most of the time when we do talk about virtualization on the server side, we're generally talking about reducing the number of servers reducing the number of physical servers, I should say, that the customer does have in place. So if we take a look at servers from a few years back versus today's ones have got a lot more cores, they've got more capabilities in terms of how much memory they can take, performance is a lot better, and overall the power utilization ends up being much lower on a machine versus machine comparison, but also when we start taking into consideration just how much consolidation we can do from multiple physical machines to a single physical machine, we really do start looking at some very, very high power savings. And obviously the power savings also have an impact on the cooling requirements, etc., space requirements inside of most organizations. So parts of this are due to improvements in the hardware capabilities that the server platform vendors have been delivering. Part of it's also being delivered by the software capabilities inside of Hyper-V. So by combining the two, you really do end up with a much more scalable solution than you have been able to get in the past. So with virtualization models, Microsoft's primary virtualization technology is called Hyper-V, and Hyper-V is available on both Windows Server and on the Windows client side as well, depending on which version of Windows that you are using on the client. But it means that you can learn it on the client side and apply a lot of those same technologies across to the server and vice versa. Now, Hyper-V is based on the host and guest paradigm, which means that you've got your host operating system under which you've got a virtualization layer, and then you can run multiple guest operating systems underneath that. And those guest operating systems can be from a variety of different vendors. They don't just need to be Windows. It could be Linux variations, for example. It could be multiple different versions of Windows Server. It just really depends on what it is that the customer needs to run. And then when we take a look at virtualization at the operating system level, we've got the host running a single operating system kernel at the core, and then it exports certain virtualization capabilities to each of the guests, but each guest must run the same operating system as host. So that's a different model versus what the Hyper-V model has, but we'll focus on the Hyper-V model for the sake of today's content. Now, important things to take note of as we look at the Windows Server scale enhancements in terms of the number of physical CPUs, memory, etc. that is available from Server 2003 to 2008 to Windows Server 2012. You can see by the numbers in the far right-hand column is that the improvement factor is generally very high. So, 5 times the number of logical processors. We've got 4 times the amount of physical memory per host. But once we start taking a look inside of the virtual machines themselves, you can see that jumping from Windows Server 2008 R2 from 4 virtual processors per VM When we look at Windows Server 2012 R2, we can have 64 virtual processors per machine. So if you do have customers that need to run highly threaded workloads such as SQL Server, for example, all of a sudden they've got a great capability to do that inside of this virtualization platform. Now, other things we can also take a look at here is the virtual disk capacity. So previously we were limited to 2 terabytes. Now we've got 64 terabytes per virtual disk. And remember, you can have multiple virtual disks per virtual machine. The number of active virtual machines, probably not that big a deal for most SMB customers, that we can go from 384 in Windows Server 2008 R2 up to 1024. But for those of you who are looking at doing some high density hosting, it means that you can see that you've got a solution here that really does scale. And now also you'll see that the clustering scale out capabilities have also improved quite drastically as well. So from 16 to 64 nodes in a cluster, and the number of virtual machines has jumped from 1,000 to 8,000 that can be managed within each cluster. So you can see that they are fairly drastic improvements there. So let's take a look at the scenario that we'll be focusing on for the rest of the module. So the company here is Contoso Travel, and I think we've all probably encountered Contoso in one form or another through various Microsoft courses. And for the purpose of today's content, they've got 250 users, they've got an international website, and they sell travel packages. They've got some Server 2008 R2 and some Windows Server 2012 servers. So they need to deploy a proof of concept to virtualize about 10% of the current workloads on Server 2012 and Hyper-V, and evaluate the performance and stability. If things work as expected, then they'll be moving aggressively forward to start phasing out some of their older server technologies. So what are some of the technologies that they'll take advantage of? Well, first of all, with Hyper-V, the server basics that they'll be looking at there are using, first of all, you've got a couple of choices here. You can do an installation via Server Manager. You can install it via PowerShell. You can take advantage of capabilities such as live migration, Hyper-V replica. You can change the default paths, and we'll walk through a lot of these things as we go through some of the demonstrations during the course of the day. Now, we'll talk about things such as parent and child partitions. So the parent partition is a special partition inside of Hyper-V where it's got higher access to certain hardware capabilities, and it's also generally where you may be doing management from, for example. Now we'll talk about some of the switching capabilities because we've got a lot of flexibility in terms of setting up private, internal and external switch types. And I'll spend a little bit of time on these as we go through some of the demonstrations. But it gives you a lot of flexibility for setting up an environment that doesn't necessarily have to reflect the customer's physical network capabilities. And now for storage, as we've mentioned, we can really start scaling things out. And we've got remote and local storage options, and again mentioning that if you do have customers with high processing requirements, we really can scale out that CPU capability as well. So when it comes to Hyper-V virtual machine basics, some of the things that you do need to be aware of, first of all, you can use Hyper-V Manager or Windows PowerShell to create these new virtual machines, and it really depends on where your skill set is and just the scale of the number of customers that you have to support. So if you're doing things one by one and not repeating the same task very often, using the GUI tools is probably a better way to go. But as soon as it's tasks that you need to repeat on a very regular basis, investing in some PowerShell capabilities is definitely going to be able to save you some time. You've got the ability to create Generation 1 and Generation 2 virtual machines. So with Generation 1 virtual machines, think of these as the ones that are backwards compatible with Windows Server 2012, whereas the Gen 2 VMs do require Windows Server 2012 R2. But we'll spend a little bit more time on that in the next slide. For the virtual machine settings, we've got the ability to add multiple types of disks. So we can add like IDE disks, SCSI controllers for SCSI disks, etc. We'll talk about VHDX files. We'll compare it to VHD files. We'll talk about the online VHDX resize, and I'll give you a demonstration of that so you can see it in action, and also the support for 4K sector size disks. So if you think back a few years ago, this was sort of something that was causing a little bit of a headache in the hardware and OS world, where the format that was being used by mechanical drives started changing from 512 to 4K disks. And there were a number of technical reasons that it made a lot of sense, but at the time there were some little hiccups here and there because a lot of the OSs out there may have only really been designed to be optimized for the 512 byte disks. But now with native support for 4K sector disk size disks, you'll find that overall, the alignment that you get inside of the virtual machine versus the physical disk, you are going to get much better performance. Now, as I've mentioned, you can have up to 64 virtual processors inside of each virtual machine, and you can also have up to 1 terabyte of RAM. So obviously for most SMB customers, you've got a lot of room to grow. So as we take a look at some of the additional differences between the Generation 1 and Generation 2 virtual machines, really the big thing to think about here is some important things are, first of all, Generation 1 virtual machines will support 32 and 64-bit OSs, whereas Generation 2 will only support 64-bit OSs. So if you're just looking at virtualizing current versions of Windows Server, for example, and you're not planning on doing live migrations, for example, to older versions of Windows Server, then Generation 2 VMs may actually be a good starting point for you because you don't have legacy infrastructure to support. But some of the additional benefits that you get, one of my favorite ones is that now that you've actually got Pixie Boot with the synthetic adapter rather than having to use a legacy adapter. So this means that you start getting much better performance if you need to do network boots to do operating system installs, for example. You can now do things such as eliminate the IDE disks. So basically the IDE controller and disks that the Generation 1 support are now viewed as legacy. So the ability to natively boot from SCSI, virtual drives, etc. is a really big benefit and can help simplify things if you are adding multiple disks or multiple virtual disks into the system. You've also got secure boot capabilities. The firmware has changed from your traditional BIOS into UEFI as well. So all of a sudden you've got the additional security enhancements that Windows Server provides now being presented to you inside of these virtual machines as well. So it ends up being a much more secure platform. So let's kick off with the first demonstration, which is exploring Hyper-V server and virtual machine configuration. If you're familiar with the Hyper-V Manager tool from previous versions of Windows Server, the good news is that you're a long way towards understanding the capabilities of the new versions of the management tool. And just an important note with this is that the commands that we're performing here via the GUI can be performed via PowerShell, so that if you do need to perform these in a manner across multiple machines and you need to automate them and script them, then PowerShell is definitely something that you should be looking at. So let's take a look at some of the options, and we'll start off just with the basic Hyper-V settings. So some of the changes I've made to this machine, so we can see here first of all that I've got Hyper-V Manager managing two different Hyper-V servers, so Hyper-V 01 and Hyper-V 02. So this is set up as a non-clustered environment, so these are two standalone Hyper-V servers. They're both part of the same domain, which means that we can do things like live migrations, etc. between them, but we'll cover that in a little bit of detail as we go through this module. So first up, we need to start changing the default locations. So instead of pointing to the C drive and documents, for example, what we can do here is set it to a more effective storage location. So in this case, I'm pointing it to the D drive, and in this case, it's just because D drive is an array that's got a lot more storage capacity as well as better performance than me storing it on the C drive, for example. If we were looking at using this for some type of VDI type scenario, we could enable physical GPUs so that we could enable the GPU through here so that remote FX will give us better performance. So we don't really cover VDI in this section or in this part one of Grow Efficiently. It's something that is covered in one of the later days. But just be aware that if you are in an environment where high performance graphics are required, even though you're running in a virtualized environment, that is still something that's incredibly achievable by using remote FX. Now, we won't worry about NUMA spanning too much, but this is really all about being able to leverage the multi-CPU type environments where applications know how to scale across multiple physical CPUs. So it's really about making sure that if a VM needs multiple CPUs or multiple logical CPUs, that it's not going to try to get them across different physical processes, knowing that there's going to be a pretty big performance impact on that because the memory bus that's being accessed may be on the other side of the CPU. So again, not something we really worry about too much in this module, but something that we can cover off in later detail in one of the upcoming events. Now, we'll skip through live migrations and storage migrations because we'll cover those in one of the upcoming demos. We've got enhanced session mode, which we can allow, which means that we can allow local redirection of devices and resources. So the important thing here is that it does require a supported guest operating system. So I'll say we can allow that because I'd like that. It's a great feature. Now, other things we can do from here is set replication configuration. We'll come back to this shortly. At the moment, as I mentioned, these aren't machines that are part of a cluster, and one of the nice things about Hyper-V Replica is that it doesn't require a cluster to be set up to get some degree of replication. So anything else that's important here, probably just the final one, is just this enhanced session mode, which we saw. Because I've enabled it, you will use it if available, and I'll just hit apply on that. Now, other changes that we can start making in here is we've got a virtual switch manager. So if I wanted to create a virtual switch, we've got 3 different types of virtual switches that we can create. You can see that I've already got a few different virtual switches created on the left-hand side. And what this means is that we can set up a virtual network topology that's quite different from our physical topology. So when we're choosing between an internal, external, or private, with external, it's a matter of what Ethernet adapter do we want to use to actually connect this VM to the network. So you can see in this case, this is a machine that does have multiple network adapters installed in it. We can also do an internal network, so that with an internal network, we can get access to the VM from the host machine, so that if we needed the VM or the host machine to be able to access resources on each other, that's something that we could do here. But then with private network, what this allows us to do is very easily go through and start building internal private networks for testing purposes that don't have any impact on other parts of the network. So if you're thinking about things like testing DHCP results, etc., testing line of business applications in a private environment with no chance of them getting out to external users, then the private network option is the one that you should be looking at here. So that's just a very, very quick look at some of these. So let's go through now and we'll create a new virtual machine and just take a quick look at some of the settings. So when we run through this new virtual machine wizard, it doesn't give us every option that's available. So let's just go through this fairly quickly. So we'll call this machine Windows Server 2012 R2. Where do we want to store it? We want to store it here, and we'll call it WS 2012 R2 as well, just to make sure it goes to the right location. And here we've got the option of the Gen 1 or Gen 2 VMs. So remember, with Gen 2 VMs, they are 64-bit only, but they also do require at least Windows Server 2012, so 2012 or 2012 R2, or Windows 8 or Windows 8.1, etc. onwards. Now, important things here are that you can't move back and forth between a Gen 1 and a Gen 2. So sometimes people say, but what if I need to move it to a down-level server? Well, sometimes it might be easier to recreate it depending on how how automated your setup process is. But other things that you could do is, you could look at some third-party disk imaging tools that may allow you to take basically the VHDX file and extract its contents and copy them from the Gen 1 and extract them out and copy them to a Gen 1 machine. But realistically, it's not leaving you with a virtual machine that Microsoft is going to be able to support if something doesn't quite go right during the process. Now, why would you use a Gen 2 VM? Well, think of Gen 2 as the way things are moving forward. So that's really the new base that Microsoft wants virtual machines to be built upon. So this includes the UEFI support, it includes Secure Boot, it gives you SCSI boot. So it removes the reliance on some of the legacy adapter types that were included with the Gen 1 VMs. So things such as your IDE disk controllers, for example, are no longer supported in here. Now, an important one and one that I always like to call out is that the Pixie boot capabilities here will now use the standard Hyper-V Ethernet adapter, so the synthetic adapter, rather than relying on a legacy old emulated adapter, which is a lot slower and a bit more cumbersome to incorporate into a new virtual machine build, only to have to remove after the fact when you do add in the one that you really need. Now, how much startup memory do we want to give it? I might say I'll give it 4 gig because I know it will start up a bit faster. And then we can enable dynamic memory. We can fine tune this in just a moment. We've already seen the virtual switches that I've set up. So which one do I want to connect this to? And in this case, I'll connect it to an external network. Now with the hard disks, we've got a couple of different options. And one of the things that you'll see here is that by default now, it will create a VHDX file and not a VHD file. Now, one of the big benefits of VHDX files is better robustness, but also when you start looking at things like the dynamic expansion capabilities of a VHDX, with VHDX files, the performance is a lot faster than with VHD files. So wherever possible, choose VHDX files. Now, the area where you do have to be somewhat more considerate about which choice around VHD versus VHDX is if it's a virtual machine that you're thinking about migrating to the Azure infrastructure as a service offering, for example, because at the moment that still only supports VHD files. So not a big issue for most people, but just be wary of that one at this point in time. So here, even though it's saying that it's a 127 gig file that it will create, think of that as 127 gig that it can potentially create. So that's the size that it can expand to, but to begin with it will start off at roughly 4 meg in size. Now alternatively, we could attach to an existing hard drive, or we could attach a hard drive later, but we'll just choose the option that we've got there. Install an OS bootable image file, so let's just go to my computer and we'll go to the D drive. I've got an ISO folder here. Let's just expand that out so it's a bit easier for you to read. And what I want in this case is the Windows Server 2012 R2 with update. And now I've got that will be mounted into the virtual machine so that installation can now take place from that. So I'll just click on finish. So sometimes people will say at this point you're good to go and run the virtual machine. But what I'd suggest instead though is jumping in and taking a look at the settings to see what else you may need to change. So at this point, we don't want to change the secure boot option to boot from DVD because DVD is the install media. But if we were planning on booting from a network adapter, you can see that it's very easy for us to change the priority here without issue at all. We saw the ability for us to have the startup RAM raised up to 4 gig, but we can also start changing the minimum RAM. So if after the virtual machine has started, things settle down a bit and it really doesn't need 4 gig of RAM, it can start releasing memory back to the operating system or to other virtual machines that are running. Or alternatively, with dynamic memory, we could tell it to go through and keep expanding up until effectively it consumes as much memory as is available. Now we can set a buffer, so this is how much memory that Hyper-V should try to reserve, so that if it needs to expand the memory, it can do so quite quickly. And then also we can prioritize the weight of that virtual machine. So if it's a more important virtual machine, we can make sure that it's got higher access to memory than lower ranked virtual machines. So that way it tries to minimize machines that are all sort of peers trying to steal memory from each other all the time. In this case, you as the administrator can go through and make this decision. So let's go through and hit OK. Actually, no, we won't hit OK just yet. We've got a few more things. So the first thing I notice here is that I've only got one virtual processor. So this machine's got, it's a dual proc Xeon, so we can actually go quite high. We could go up to 32 cores per VM, but in this case, we don't really need to go up that anywhere near that high. This isn't going to be doing much more than AD in this case. So other things that we can start doing from here is we can control the resources, so setting a percentage aside for the virtual machine reserve. We can do the virtual machine limit, and we can also set the relative weight. So again, determining is this VM more important than other VMs that are running. Now, I won't go through too many of the other options here. Just one of the things that I will quickly highlight is for the network adapter. Some of the things here around the hardware acceleration, you can see that we can enable that virtual machine queue. We can enable IPsec task offloading. We can also enable single root IROV. So we can go through and basically make it, give it more of a hardware accelerated experience when it is dealing with network traffic. Now, there are other advanced features that we've got access to. Won't go through all of these, but just a couple of things to point out here is things such as DHCP guard, so that if there are other virtual machines trying to issue DHCP IP addresses via DHCP, it won't allow it. We can block router advertisements, etc. We can do mirroring, so that if we want to take the network traffic of a VM and push it to another VM for interrogation or for analysis, we can do that quite easily here. And we can also do things such as enable NIC teaming here at the virtual machine level. Now, the final thing that I'll just show you here is the automatic start action. So this is an important one because this will determine what happens if the server loses power unexpectedly, for example. So if the server someone pulls the plug and you plug it back in, do you want it to do nothing, so basically stay offline? Do you automatically want it to start? Do you want it to start automatically only if it was already running? And then other things that you can start doing here, depending on the I/O capabilities of your disk subsystem, is do you need to start introducing delays to the VMs? So instead of having, I think this machine has got about 40 different VMs loaded, and I know that if I tried to kick off all 40 virtual machines immediately at system startup, it's going to take a long time, and the disk read queue is going to be pretty atrocious, to put it mildly. So we can start staggering the startup times for these so that the virtual machines that we want to start fastest, so something such as we may say, okay, what's important to the organization? So it might start off with, okay, a domain controller fires up first. Then if we've got some kind of routing appliance, that can then start up. And it's really up to you to determine what the priority is based on what is going to have the best overall impact on the organization. So then once I hit apply, that's it. That's the process of going through and creating the VM. So let's start that off just so you can see this fire up quickly. Now I can just click on start. And here we go, and we are on our way to a Windows Server 2012 R2 ISO-based installation within the virtual machine. So obviously, if I wasn't giving you the running commentary, we could do this in a very, very short time period. But I don't need to keep that running for now. That's just for demonstration purposes. So let's just save that one, and we can come back to that later if we need it. Let's jump back into the slides and continue on with the scenario for Contoso Travel. So what we have here is a bit more detail about the scenario, and in this case Contoso is concerned about the workloads that they want to virtualize and whether or not they can actually handle the network I/O. So this may be something that's been triggered because in the past they may have just had gigabit Ethernet, which while initially is a huge upgrade over 100 meg Ethernet, it doesn't take too long for you to start coming up with different types of workloads, especially when you start doing storage across the network and virtualization, that you can really start pushing gigabit adapters very, very hard, very, very quickly. So some of the things that they're looking at with the new servers is making sure that they've got the latest virtualization chipsets. So obviously, as new generations of CPUs have become available from AMD and Intel, the virtualization technologies that have been offloaded from software to hardware, that list just keeps getting longer and longer. So we're at the point now where these improvements just do allow this very, very high density virtualization versus what we've been able to achieve in the past. We've got support for uniform memory architecture support. We'll talk about that in a bit more detail as we get to the slide. And we'll also cover the 10 gigabit Ethernet adapter support, which is built in. So in this case, they're buying servers and they're including dual 10 gig Ethernet adapters in there. So we'll address how do you deal with having those two 10 gig adapters. How do you actually take advantage of making the two of them work together? Now, the second piece is that the memory requirements do change from day to day. So there'll be certain workloads that, at some points in the month, for example, when there's end of month reporting, things like some of the SQL instances may need a lot more memory than they're currently getting access to, for example. So they need to know what kind of technologies are available that can actually release or grab memory as needed without having too much of an impact on the rest of the overall environment. So let's jump in now and take a look at a few more of the networking improvement details. So first up, we've got receive side scaling. So this is something that was introduced with Server 2012 R2, but what it does is it allows you to start spreading some of the workload from the CPU across multiple physical and virtual cores inside of the CPU. So instead of one core, for example, getting pegged pretty hard with network traffic, instead it's something where it can distribute that load, which means overall you get a much more responsive performance. So what also happens from here is that you've got the ability to now start taking advantage of virtual receive side scaling, which suddenly means that this is something that now allows you to scale within VMs with multiple virtual CPUs as well. So it's taking that physical concept that was introduced with 2012 and extends it now to virtual machines, not just to physical machines. So we're talking about some pretty major improvements here. Now, we've also got the virtual machine queue, or the dynamic virtual machine queue. So this is where we can start eliminating CPU zero bottlenecks. So again, as soon as there's a lot of network activity, instead of a particular CPU having to take the brunt of the load, it can be spread across multiple CPU cores. So once again we keep a much more responsive server. And remember that if we can keep CPU zero free on a server, it means that overall it is going to be much more responsive, because there are generally a lot of things that are trying to take advantage of CPU zero. So the more optimized it is, the better everything is going to run in general. And now the final thing that we've got here is the single root IO virtualization, or SRIOV. And what this gives us is a standard. It was introduced by the PCI SIG, and what it does is it works with the system chipset to allow virtualization technologies to take advantage of capabilities of the physical NIC itself. So in this case, we can take advantage of things like direct memory access, etc., so that we can really leverage the capabilities of the network adapter that's inside the machine. So we start getting better performance. So if we think of it more like pass-through performance rather than something that's being heavily virtualized before it hits the network adapter. So what this does is it increases network throughput, it reduces network latency, and again, it's another thing that helps to reduce that host CPU overhead. So remember, with these kinds of capabilities, the more that we can offload from software into the hardware capabilities, so whether we're talking about the network adapters, the chipsets, or the CPUs themselves, the more that we can actually offload into hardware instructions, the more performance we can get from the server and the more scalability we can get as well, which is obviously very important when we're virtualizing workloads. Now, with dynamic memory, it's best if we walk through what's going on with this. But this is something where if we talk about some workloads where they may only have high memory requirements at a certain point in time. So even if you think about some virtual machines, that that a machine might start a lot better if it's got 4 gig of RAM, but then you'll notice that once it's actually running, it may only really require 2 gig of RAM, for example. So this is something that allows you to do things such as set minimum and startup memory requirements to be different. So the startup memory might be higher, then it could drop. You can set dynamic memory so that the amount of memory can expand if the virtual machine requires it. And then what you need to do is really just sit down and balance out, which machines have got the highest priority. So even though Hyper-V will try to juggle this for you, obviously you've got more knowledge of the workloads and how important they are to the customer. So this is something where you'll need to sit down and you could just leave it as is if the server has got a lot of memory, but if you are going to be running in a memory constrained server with lots of virtual machines, you might want to sit down and do a little bit of tweaking to make sure everything runs well. So let's go through some of the capabilities here. So first of all, as I mentioned, we can set the minimum memory and the maximum memory that are required, and these will come out of the virtual machine physical memory pool. And then over time, as the amount of memory required starts increasing, it'll hit a wall, at which point it will request Hyper-V to be able to start getting access to additional memory. And the minimum and maximum memories, in this case, the maximum memory can actually be increased without restarting the VM. So that's a nice improvement. Now, what we can also start doing is take advantage of smart paging. So smart paging is a way that it really has a specific use, but it's where it will use a portion of storage on the physical media to emulate RAM in a very, very particular situation. But what its goal to do is to provide a reliable way to keep a VM running when the server is very, very physically memory constrained. So the startup of that VM may actually be a lot slower, because if it's hitting a mechanical drive, or even potentially an SSD, which is still slower than system memory, there are going to be some performance penalties as you restart that VM, but then it should be back up and running. So it's only used in very specific situations. So virtual machine restarts if no physical memory is available, and then no memory can be reclaimed from other virtual machines on that host. So it really has to meet those requirements in order to be used. It's not just something that you can kick in and use whenever you feel like it. So when it does start up with smart paging, it will go through, it will take advantage of that physical space as emulated memory. So think of it, effectively as something like a swap disk, which does also emulate memory, to allow you to potentially run more things than you really should at the same time. But remember that it's just a temporary transaction that is taking place here. So that paged memory is removed after the virtual machine is restarted, and effectively from there it should have enough memory to keep running. And realistically, if you are when you are planning out a server, a lot of the time you're probably going to put in more memory than is really needed, so this situation can be avoided. But over time, as you do start building more virtual machines inside the network, what you'll probably find is that you may actually start encountering this. So just be aware that it's something that you can leverage to allow you to keep more virtual machines running in a very reliable fashion. Now, as we jump in and take a look at the next slide, resource metering, we'll only cover this one briefly because for a lot of SMB customers, it's not really something they need to worry about too much. It's more of an issue if you are looking at providing hosting capabilities to your customers and you do want to provide some level of build-back capabilities. You can leverage these capabilities. But what we can do here is we can set up resource pools. So in this case, you can see we've got the HR department on the left and the sales department on the right. And what we can do is go through and have things such as CPU use, memory use, disk allocation, network IOPS in and out, storage IOPS, and network traffic in and out, all being monitored and metered, so that if you want to start charging back based on usage, this is something that you can do quite easily with the resource metering capability. And what happens here is that all of the departments are sharing the same infrastructure. It's just a matter from a reporting perspective, you can actually start isolating things so that you can figure out who's actually really hitting the server quite hard. So what we can start doing here is we can see that we've got the amount of use. So we can see that the virtual machine resource metering is saying that, maybe based on certain costs, etc., that we're reporting. We've got 45 units of use from the virtual machines in the HR department. We've got 40 units from the sales department. And then what we can start doing here is, once that activity starts taking place, we can also start looking at the internet resource metering as well. So, which ones are using more connectivity? So do you have a cost associated with the amount of bandwidth? So these are ways that, if you think about it from an SMB perspective, you're probably not going to go down this path for the smaller customers. But as soon as you start talking about larger organizations or a hosting type situation, these kind of capabilities really do start making a lot of sense. Now, as we take a look at the next scenario that we'll start introducing, this is where the customer wants to be able to take advantage of live migration and live storage migration, which can move workloads from one Hyper-V host to another while the virtual machines are still running. So when we start looking at this, some of the issues that Contoso starts raising with us is that, first of all, they don't have a lot of money to go out and spend on expensive SANs, etc., which they may have looked at in the past. And they just want storage to move when a VM migrates as well. They want things to be nice and simple. So in this case, because they are going to be relying on this network infrastructure quite heavily, the servers are going to be equipped with what are called RDMA network adapters. So these are very high performance network adapters. We'll talk about them in a bit more detail as we go through. But effectively they allow in-memory transfers of data from one server to another. So we really are talking about very, very high performance transfers. And the reason why they're looking at this is that they want to centralize the storage of the virtual machines, of the physical disks that they're using, and maybe have them move between Hyper-V hosts without having any real impact on performance. So let's jump in and start taking a look at some of the specifics. So first of all, with live migration, what we've got here is the ability to very, very easily start moving virtual machines from one physical host to another physical host. So you can have very fast live migrations, you can support multiple live migrations at the same time. And if you do have these RDMA or what's called SMB direct network adapters, these are very, very high performance. So if a 10 gig network isn't enough for you, then RDMA may be what you're looking for. Now, when it comes to what kind of storage can it connect into, it's very flexible. It's like, is it something that Windows can support? And if the answer is yes, so it can do it as well. So some of the things that are mentioned here are iSCSI support, fiber channel support, as well as SMB storage support, or your traditional file and print. But the traditional file and print is something that is very, very different today versus what it used to be. And we'll spend a little bit of time talking about SMB 3.0 as we go through more of this content. So what we've got here is an IP connection is established between the two Hyper-V hosts, and what's happening here is that Hyper-V host 1 is communicating with Hyper-V host 2 because you've said you want to move that virtual machine from one server to another. And in this case, because we've got shared storage, we don't really need to move any storage. The storage can all stay put on that back-end infrastructure. So what we can do here is shoot the configuration data across, and once that configuration data is copied across, the next step is to start copying across what's sitting there in system memory. So obviously if you've got a virtual machine with 512 meg assigned versus a virtual machine with 8 gig of memory assigned, the performance difference is obviously going to be impacted by that. But this is something that allows it to do very, very fast migrations, especially if you do have good network connectivity here. Now, once those modified pages are transferred across, it will get to the point where everything is actually in sync between the two of them, and then it will automatically cut across from from that first virtual server across to the second virtual server host, and all of a sudden we've got that virtual machine running on the second target host, and from the user perspective, they shouldn't have seen any interruption whatsoever. Now for storage migration, this is a little bit different, but what we can do here is we can actually do migration of storage from one network location or a local location to a remote location or vice versa. So if we build out a virtual machine and accidentally save it in one location, and then we go, oh, actually we wanted to store it in the storage array, it's very easy for us to go through, and while the VM is running, we can choose to move the data, and what will happen is the data is copied from one location to another, and while that's happening, effectively, the original data needs to be written across, but then it will get to the point where once it's got all the original data, it will start writing data to both locations at the same time. And once it gets to the point where it's in sync, then the virtual machine will only be communicating with that new device or the new storage location that you specified. So this gives you a lot of flexibility, as you can see, so that you can move data if you realize, oh, you've accidentally installed it on the C drive, which is probably not a good place for it. It's very easy for you to move it across, and there's no downtime. So in this case, the virtual machine is still running on the same Hyper-V host, so there was no in-memory or there was no transfer of in-memory data, for example, because that all stayed on the host. It was actually the back-end data that moved from one location to another. So let's jump in now and take a look at Hyper-V live migration so you can get a better indication of how that works.
So now that we've created this virtual machine, one of the things that we skipped over quite quickly, because I said we'd come back to it, is if we go back to Hyper-V settings, one of the options that we've got in here now is live migrations. So with live migrations, what we've got is the ability to allow the incoming and outgoing live migrations, and then how many live migrations we can actually run at the same time. The default is 2, and this is based on the assumption that the customer may not have high throughput a high throughput disk subsystem, for example, it works on the assumption that the customer may not necessarily have high speed networking. And we're at the point where 1 gig from server to server can't really be classified as high speed because we can definitely start taking advantage of much higher network performance. So what I might decide here is, because I know that I'll have to do more migrations over time, I'll say 10 is a good number. And for incoming live migrations, I'll just say, because this machine has got lots of IPs, just use any available network for live migration. But in reality, you may have a network environment where you've got a storage network, you may have a management network, you may have the actual network that people are using. So you may want to limit the networks that are actually being used through here. So the UI to add these is quite simple. We can use the IP address, we can use the range, we can use the IPv6 details as well. But we'll use any available just for the sake of simplicity for this demonstration. So now that we've done that, we'll jump in, we'll take a quick look at the advanced features. We can use CredSSP, we can use Kerberos. I'll choose Kerberos for this one. Do we want to do compression? So compression is an important one because it means that we can reduce the amount of time it takes to send that data across the wire. So for now, compression is a good one, but the other options that we've got is copying it across using TCP IP and then also just using SMB. So in this case, if we do have an SMB direct adapter, that will be used to give us really about the best performance we can actually get out of these different scenarios. Now we've also got storage migration capabilities. So if we want to work with different storage migration options, again you can see that the default is quite low at 2, but I could change that very easily to 10, hit apply, and that's it. So we've now got the ability to really run a lot of different migrations at the same time. So if we're in a situation where we need to really quickly start flushing virtual machines off this machine out to other machines on the network, and those machines have all got good connectivity to this machine's got multiple network adapters, bumping that number up from 2 is going to allow us to really make the most of the network resources that we do have available to us. So what we can now do is, with this virtual machine that I've got here, I can decide that I want to move this across to another virtual machine, into another Hyper-V server. So if I click on Move and we take a look at the different options, the option that I want here is to move the virtual machine. So in this case, it moves the VM and the storage to another computer running Hyper-V. Now, if this had shared storage configured, I could just move the running virtual machine without having an impact on the storage itself. So in that case, if it's only got to copy across 8 gig of in or 4 gig of in-memory contents, that's going to be a much faster transfer than copying the 4 gig that's in memory, for example, as well as maybe the 10 to 16 gig of storage that may be in use. So where do I want to move this to? Well, it's on Hyper-V 2 at the moment, so I don't really have too many options. I'll send it to Hyper-V 1 and we'll click on Next and we'll see how that goes. So how do we want to do this? We'll move the virtual machine's data to a single location. That's fine with me. And you can see here the different options that we've got. So do we want to move the machine's data by individual selection? So do we want to move the configuration files, for example, to a different location to where we're moving the VHDs? In this case, we don't really have our disk subsystems or network set up optimized for that. Or do we only want to move the virtual machine? So this is the option where we can move the virtual machine without moving the hard disks. So as soon as we've got shared storage capabilities, so in this case using SMB 3.0 is definitely going to do this job for us. But in this case, we'll choose that first option because for now it's more likely to be what people have got. So when we take a look at the destination folder, what do we have? Now, important thing to note here is that now we're in a remote file browser. So I'm not on Hyper-V 2 anymore. It's actually pushing me across the network to another server. And what I'll do here is, even though it's not a good practice, I can see those other drives are getting fairly low on disk space. So I might have to do give a call to some of my storage vendor suppliers and say, let me just copy it to the C drive, and we'll select that folder and we'll just go to the summary, and the move method is compression, which is what we said was okay. And this is actually an interesting one here. So what this is telling me is that there are capabilities that Hyper-V 02, which is a later Xeon series, can't perform that Hyper-V 01 just isn't capable of. So what it's telling me here is if we take a look at it, the operation cannot proceed unless the errors are resolved. So do I want to delete the saved states producing these errors in order to continue? So in this case I'll say yes, because I haven't really progressed very far with this VM, but in reality you probably are not going to click on delete save state if it's a running VM that you've just suspended for some reason. The better option is to fire the VM up and then shut it down, so that it's basically starting with a clean slate, and then it will detect the CPU capabilities of the new platform that it starts on. So now let's try that one again, and let's see how we go. So that's okay. It's saying that on that remote server, I don't have a matching Ethernet switch called external. So which one do I want to put it to? Well, this is a bad practice on my side because I should have identical names across them. So I can just check external. So this gives you an idea that instead of it just trying to move it across to the other machine and running into all manner of errors, these are things that we're very easily addressing here before we even begin that migration. So now if I click finish, what we should see, we'll let it run through its checks. And it's performing the move, and what we do here is we'll see that it's sitting there. So that's Windows Server 20, actually, so that's a different VM. That's the Essentials VM. If we go now up to Hyper-V 01, what we can see here is the Windows Server 2012 R2 VM, that one we just moved across. So that's it. So that moved it across. Even though I didn't go through and clean it up and get everything ready the way that I was supposed to, it still gave me enough of a nudge in the right direction to be able to get that live migration to work.
Okay, so we've taken a look at some of the live migration settings. So let's jump back into the scenario and see what other things that Contoso are looking at doing. So as we start breaking through the scenario, we can see that there's a few new things that we need to start thinking about. They've got SQL Server, which is running in a cluster, and they've recently invested in some SAN hardware. But as I mentioned previously, they're finding that the cost of the SAN hardware is quite high, and they really don't want it to take up a huge proportion of their deployment funding that they've been made available. So they want to make sure, though, that they can still take advantage of certain SAN features, so that they can take advantage of capabilities such as offloaded data transfer, or ODX, which allows very large data file copies in very short time frames without really stressing the host machine. So we'll spend a little bit of time talking about that to begin with. So as we take a look at offloaded data transfer, it's best if we walk through the steps, but first of all, let's take a look on the left-hand side at the list of things that it provides. So it allows rapid virtual machine provisioning and migration. As I mentioned, it allows very fast transfers of large files. So effectively, it's taking advantage of whatever the fastest path is if it's disk to disk or high-speed network from one disk to another disk. It can take advantage of that regardless of what device it is that you're using to initiate that copy. So it keeps latency down. It can take advantage of high-end hardware storage arrays. Network use and CPU use can be minimized, and performance isn't limited by the network throughput or server use. And it really allows you to start getting better scale in the data center. So let's take a look at the animation here so we can get a little bit more information here. So first of all, we have an offload copy request. And what we want to do here is copy from one storage array to another storage array. So we can think about those storage arrays being connected in multiple ways. So the first thing is that they may be two storage arrays inside of the same physical device. So it may be a Windows Server 2012 R2 with two separate storage spaces, and you want to copy from one to another. So obviously you don't want to copy things out across the network and back into the machine. So in this case, it's a matter of we can do disk to disk. But it could also be that, as we can see is the case here, we could also be doing this across a network, in which case we can just be pushing from one of those locations to the other. So what happens with the actual data once we send that copy request is a token is received, and what occurs, the token is pushed across to the other server, which gets that write request token, and from that point on, what happens is the
data is moved from the one virtual disk to another virtual disk, and then it comes back up and is reported as successful. So with that storage array, the speed of that copy is really going to be dependent on the performance of the the array or the arrays that you're actually copying to and from. But as I mentioned, it's not actually necessarily being impacted by the performance of your network. Now this allows you to do very large copies across the network without it pulling something down to your machine and then pushing it back up again. So while it does work extremely well for things like virtualization, it also works very well in other cases where you need some additional features over and above what a traditional SMB file server provides. Now, as we take a look at virtual fiber channel inside of Windows Server 2012 R2, this was a new feature that was added. So fiber channel support has been in Windows Server for quite a while, but in this case what it is that now all of a sudden you can actually have that fiber channel SAN access directly from the VM itself. So you have direct access to the SAN, you've got hardware-based I/O path, so basically you can really take advantage of the high performance that you can get through fiber channel. You can have one Hyper-V host connected to multiple SANs, and you can have up to 4 virtual fiber channel adapters per virtual machine. So if you do have multiple paths through to the data on your network, then multipath I/O makes sure that it's not going to go through and go, start reporting multiple copies of the same storage instance for you. And it also supports live migration, which is one of the nice ways to be able to really push a large amount of data in a short time frame. So let's take a look in a little bit more detail with this. So what we want to do here is we want to take a look at that worldwide name set A, and what we can do now is do a live migration across to virtual machine 2, and in this case the live migration is happening across the fiber channel. So we end up with a situation that once everything is migrated and synchronized, then like we saw with some of those other situations around storage migration or with live migration, then what we can see is that once the new node has got all the data, it can actually pick up and run, and there's no impact to the client machines that are connecting. But now one of the ones that I guess is going to be used by a lot more SMBs rather than those who've only invested in fiber channel infrastructure is being able to take advantage of Hyper-V Replica. So with Hyper-V Replica, this is really all about having an interval, either 30 seconds, 5 minutes, or 15 minutes, from which you can start replicating changes in virtual machines from one Hyper-V host across to another. And one of the things that's been added in Hyper-V Replica with Windows Server 2012 R2 is the ability to now replicate not just from the primary site to a replica site, but now to a third location as well. And we'll speak about that one in the next slide. So with this, it means that you've got replication technologies included right in box. So in this first scenario that we've got here with the primary site and the replica site, this could be, primary server 1 and primary server 2 both in the same location. It may not necessarily be pushing data out to a replica site, but obviously if you are pushing this out to a replica site, it means that you do get better availability of data, because if there is a natural disaster at the primary site, you know that you've got a recent copy of that virtual machine that's been replicated and updated across at the replica site. So how do we take advantage of the extended replication? Well, with this one, it's pretty easy. All we do is we set up a third replica, and you'll see that in the upcoming demonstration, so I'll show you the steps that are required to set that up. But once you've got the VM set to go from the primary site to the replica, then you can go through and set up the second replica very, very easily. And it's chained replication, so it has to go from server 1 to server 2 to server 3. So you need to make sure that it needs to travel across both of those paths. Now, the extended replica contents will match the original replication. You've got some flexibility in terms of how much of that incremental data you want to send, because obviously in some situations you may be sending it across high-speed networks, but in other cases you may be limited to your internet connections. So you need to start thinking a little bit smarter around how you start triggering that replication. And what you can do here is you could have the primary to replica site, the initial replication operating at a high frequency, but then reduce that frequency from the replica site to the DR site to take that the amount of data or traffic into account. So
in this case, what you could do, so some customers may say, well, look, we've got two locations, we'll do Hyper-V replica from one of our sites to another one of our sites, but then they could use one of you could be a hosting provider, or you may be working with a hosting provider that can then provide that third layer of protection for them. So instead of talking about it any longer, let's jump in and I'll do a quick demonstration of the capabilities of Hyper-V replica for you. Back in our Hyper-V environment, let's take a look now at what's required to set up the Hyper-V replication service. So the goal of this demonstration is for me to be able to replicate this running virtual machine, the Windows Server 2012 AD VM, from Hyper-V 02, where it's currently running, to make sure that I've got a copy of it that's also running up on Hyper-V 01. So when we do talk about Hyper-V replica, we're not talking about a running instance of the VM. Instead, we're talking about a copy of the VM that's ready to go in case we do need to switch across to that. So let's go through that process quickly. So let's jump back to the original server where it's actually sitting. And what we need to take a look at here are the Hyper-V settings, and we need to take a look at replication configuration. So we've got a couple of different options here that we need to be aware of. So the first one is to allow the server to act as a replica server. Then we get to choose whether we want to use just port 80 and standard HTTP traffic with Kerberos authentication, or alternatively, if we want to use certificate-based authentication using HTTPS. In this case, because the traffic is being replicated across the network and potentially across just a secure storage network, in this case, I'm not going to select the HTTPS option. Now, as we go through and we take a look, we need to set the authorization. So where do we want replicated virtual machines from other Hyper-V servers to come if they're copied to this machine? And here's the location. I probably should set it to something else, but at this point I'm not planning on replicating to this one. What we can do here is, instead of allowing replication from any authenticated server, we can actually specify which servers that we do want to replicate from. So that way we can be a bit more specific. So if we don't want other Hyper-V servers that are being built by perhaps other organizations inside of our company being replicated to us, we can choose that allow replication only from the specified servers. So there's not a huge number of things that we need to change on this side. So now let's jump back into Hyper-V 01. And because we can now just take a look at its settings through Hyper-V settings, we can take a look at the same thing here. So first of all, making sure that we've got a matching set of protocols that we can actually use. So making sure that we can actually use HTTP across both. Where do we want to copy the files to? So in this case, those virtual machines that I'm running, I want to bring them across to this REPL VMs folder. So I'll just select that one. And again, you'll see it's the same options. We don't really need to change too much here. So this one is just going to be receiving those new VMs. So now quickly we jump back to Hyper-V 02. Now once we're in here, what we can do is just go enable replication, and now we can just run through the wizard. And it's a fairly simple wizard, so it won't take you too long to come to grips with this one. So we can choose the replica server. Well, I've only got one other Hyper-V server running in this environment, so Hyper-V 01 is the appropriate location. I can't choose a different set of credential types because I've only got one set up. But if we did have a server that allowed both options, then we could choose one or the other. Now, also here we've got the ability to compress the data that's transmitted over the network. So with this one, it's really a trade-off here, whereas if you're talking about a Hyper-V server environment where the Hyper-V servers are incredibly CPU bound already, adding additional compression workloads to those servers, even though it's going to be doing it as a background task, it's got the potential to have an impact on the server's performance. So instead you may say, well look, we've got plenty of network bandwidth, so it doesn't really matter if it takes a little bit longer and consumes more bandwidth. But obviously if you are looking at pushing this out across a slow connection rather than across gigabit or 10 gig Ethernet, you probably do want to go through and compress that data. If we do have multiple virtual hard drives inside of the VM, then we can choose which ones we want to replicate. So if we've got, in this case, we've got one that's the operating system, we may have another one for the application, may have another one for a database. We may decide that we don't want to replicate all of them, or we may decide that we want to replicate all of them. What you're trying to sort of plan for, though, is that you need to make sure that that VM will be able to come back online when you choose to start it. So make sure that it's something that does run the way you want.
Now we've got three different choices for the replication frequency, so 30 seconds, 5 minutes, or 15 minutes. And again, the types of things you need to think about here is what the impact is going to be on the network and on the system. So in this case, it's something that I want to keep fairly common or fairly up-to-date copies of. So 30 seconds might be a good option, but if we are going across a slower connection, dropping to 15 minutes may be a better option. Now we can also choose between the level of recovery points that we want. So do we want the latest recovery point? Do we want hourly recovery points? So what you have to remember though is as you start allowing more recovery points, it means that you're starting to generate more network traffic, etc. You're generating more disk space required. So you've got to think about the overall impact that's required if you are going down this path. Now, for the initial replication method, the important things here are that we can either do it across the wire or we can do it by copying to external media. And then if we do copy it to external media, then we use that third option. So once that external media has been copied, we could then choose this option here, use an existing virtual machine on the replica server as the initial copy. So if we've already restored a copy of this VM over on the other side, we can basically do a delta update between those two VMs. But in this case, we've got two servers sitting a couple of inches apart from each other, so send initial copy is the right option. So schedule initial replication, I want that to start immediately. First of all, just to make sure that it actually works. So there's the summary. Let's click on finish and we'll see how that progresses. So one of the things that we can start doing here is once that's running, we can see that it's sending the initial replica, but we can also now jump down to this replication tab to see what's going on here. So because this is the first time that the replication has been run, it's telling us initial replication is in progress. We can see the primary server, we can see the replica server, we can see that this is the primary server, and so far, even though it hasn't completed, it's reporting that progress is continuing, so it's not reporting any issues. So if we jump up to Hyper-V 01 now, what we should see is that we've now got Windows Server 2012 AD sitting up here, but as we scroll across, we can see that it's now receiving the changes from that Hyper-V 02 server. So that virtual machine is being picked up and moved across as we speak. So let's take a look at what's happening with that one. So if we take a look at Task Manager, what we can see here is that there's the network traffic that's being generated as that's being pushed across the wire for us. So that's going to take just a little bit longer to occur, but what we can see now is if we click down on the replication tab, it tells us that this is the replica. So if we're wondering what this VM is, we thought we saw it on another machine, just jump into replication and you can see what's going on with that. So again, we'll see that it's still pending that initial replication, but let's watch that. So it's not going to take too many more seconds for that to complete so that we can actually see what the finished product looks like, and then we can jump back to Hyper-V 02. So here we go, that's almost done. Now it's saying it succeeded, so what we now see is that replication is enabled and replication health is normal. So if we take a look at what's inside of here in the settings, we'll see that it's replicated the settings that it picked up from the other location. So effectively, we need to make sure that if we do expect to be able to bring this online in this environment, that it matches the requirements so that there's enough memory, etc., that any of the variables, so any of the network adapters, etc., that we've configured, that the virtual switches match each other on the different Hyper-V servers. So the final thing now to show is if we do just jump back to Windows Server 2012 AD and we take a look at the replication settings, what we can also do here is we could also now choose the option to extend replication. Now, I don't have a third replica server set up in order for us to do this, but if I did have a third server, I could now add this third server, and this could be a local server, or in a lot of cases it may be a remote server, potentially even with your hosting provider of choice, so you can now push these replicas up to that remote location. So because I don't have the third replica server running, we can't do that step here, but you can see that the steps that are listed here are pretty much following the same process. So everything that we saw to go from server 1 to server 2, effectively we're choosing the same options to go from server 2 to server 3, except we don't get the granularity in terms of time. We can't really shrink it down to that 30-second delta that we've currently got set. So that's just a very, very quick look at the Hyper-V replica capabilities, and that will now go through, and every 30 seconds an update will be sent through. And overall, you've seen that it's a very, very quick process for us to be able to set that up and start having that those VHD files replicated across multiple Hyper-V servers.
So with that Hyper-V replica demonstration, that brings us to the end of this module. So what are we going to be covering next? So next we'll have modernizing legacy infrastructure and applications. So we'll start digging a little bit deeper to see what's required to move people away from old versions of Windows Server up to current solutions.